name is Preuss, and I'm an academic working in structural materials, particular metallic materials, materials which are used in highly demanding environments. Midas is a program grant funded by EPSRC, and it focuses on mechanistic understanding of irradiation damage in fuel assemblies. Midas will bring together research we currently do in the field of cladding material, and that is the cladding material which encapsulates nuclear fuel in modern light water reactors. What is new here is that we, rather than focusing on individual aspects of how the material degrades in a nuclear reactor, we will bring it all together and provide a much more holistic understanding of the degradation of those materials. The research we will be carrying out within Midas will provide new insight in terms of how the materials corrode, how they react to irradiation damage, and so forth. And the impact of the research will be very much on providing the underlying understanding for industry to develop new safety cases for fuel assemblies, which then will enable the industry to operate these fuel assemblies for a much longer time. At the moment, what happens is that these fuel assemblies, they're taken out when 40% of the fuel is still left in there. And it's very much about the cladding material, the material that encapsulates the fuel and its structural integrity. If that structural integrity is not guaranteed anymore, then the fuel has to be taken out regardless if fuel is still left. So Midas aims at providing much better understanding about the degradation of that encapsulating material, the subliminal. And we hope that with this new understanding we are going to develop, we will be able to provide the understanding for industry to take forward, to develop new, more physically informed safety cases, which will then allow the fuel assemblies to stay inside the reactor for much longer and produce more electricity.